This is target number 6 from the Sycamore Math Invitational this year. And this is a really nice calculator combined with logic problem. When you look at it, the temptation might be to try to do some algebra on it. And that's a good temptation, and there might be some algebra you can get away with. But I'd rather you look at it more from a number theory perspective, which is to say, well, what can we know about these solutions A, B, and C based on what we're given? Well, the first thing is, for A and B to add up to 65, one of them has to be positive, and one of them has to be odd, and one of them has to be even. And that in and of itself gives you a lot of information, because that tells you that C is a odd number, because an even number squared plus an odd number squared is always going to give you an odd value, and so you know that C is an odd number. And then the second thing you know is that if you try things like 32 squared plus 33 squared, you get 2,113. Or if you looked at it instead from the opposite extreme, 1 squared plus 64 squared, you get 4,097. And if you started playing around with it, you will find out that this, when they are as close together as possible, is the smallest a squared plus b squared can be. And this, when they are as far away as possible, is going to be the greatest that a squared plus b squared can be. And again, you can go through and just play around with that a little bit to convince yourself of it. So if I take the cube root, again, this is where the calculator comes into play. If you're not sure how to take the cube root on your calculator, it's raising it to the 1/3 power. You get the cube root of this gets 12.83. And then if you take the cube root of 4097, you get 16.01, which means if this is the smallest it can be and this is the largest it can be, you only have two options, 13 and 15. And so there's only two possibilities here. Now, if I start looking at a few things, first off, I know that if I consider 13 cubed, I get 2197, and then if I consider 15 cubed, I get 3375. Well, at this point, you can either trial and error your way there, but when you're trialing and error, it's often a good idea to have some a nice way to accomplish this. And one way you can do that is by looking at the units digit. And so if I consider my units digit, so for example, 32 squared plus 33 squared gives me a units digit of 3, right? Because 2 squared plus 3 squared gives you 13. And so that gives you a units digit of 3. If I did 1 squared plus 4 squared, another way to get 65, I would get a units digit of 17. If I did 0 squared plus 5 squared, I would get a units digit of 5. If I did 9 squared plus 6 squared, that would give me a units digit of 7. If I did 8 squared plus 7 squared, that would give me a units digit of 3. Now, if you notice, it just goes backwards, and you've actually tried everything that you can. These are all the possibilities of units digits that are going to add up to 65 for you. So if I wanted to find one that ends in 7, I've got to either do things that are like 31 and 34, or 21 and 44, or 11 and 54, or I need to do them as these. If I wanted to end in 5, it has to be this. Well, it actually becomes very easy to verify that it cannot be end in 5, because that's the only way to do it. If you go through and you do 30 squared plus 35 squared, you get 2125. If you do 25 squared plus 40 squared, and if you went through and calculated all these, first off, you're seeing that we're not getting anywhere near close enough, and so I'm going to try to shorten this a little bit by doing 50 squared plus 15 squared. That gets me 2725. Still not big enough, and so I'm going to try 60 squared plus 5 squared. That gets me 3625, which is too big, and so I can try 55 squared plus 10 squared. and that gets me 3125. And you can see these are all those possibilities that end in 5, which in and of itself gives you the logic that it has to be 13. But if you didn't go through and find that logic, you could also just try all these things, and it turns out that if you do 26 squared plus 39 squared, you get the 2197. And so it turns out that 13 cubed equals 26 squared plus 39 squared, which, by the way, if you think about factoring out a 13 squared from both of those, you're left with 2 squared plus 3 squared, which equals 13 of itself, which shows you that it's 13 cubed. Once you knew that the answers were these two, that might have been a good idea to think about, well, what's 13 cubed? 13 cubed is equal to 13 squared times 13, but 13 squared times 13 is equal to 2 squared times plus 3 squared, which shows you that the answer is 26 squared plus 39 squared. So again, not a lot of direct math, but a lot of logic used to come up with our answer of 13.